Okay, number 17. X is not approaching infinity, so we don't do the comparison. We go right to the green step, which is we're supposed to factor and divide. So you should rewrite the limit statements, right? Equal. Okay, I've been showing you some things where you can do it in your head and you won't suffer any penalty. This one, I believe strongly that if you don't write it down, you'll just get it wrong. So it's not that they're going to penalize you if you don't. If you do it all in your head, if you get it right, they'll still give you the point. But it is risky. So anyway, rewriting it, limit as x approaches -4. That looks terrible. The bottom factor is the easiest, so I'm going to start there. Bottom is going to be x minus 4 multiplied by x plus 4. Questions? Yeah, I think I mentioned this earlier today. The only reason for factoring usually is so we can divide. Therefore, I know, well, I'm pretty confident, it's not guaranteed, that one of the factors on the top will have to be either x plus 4 or x minus 4. So, here we go, x and x. Okay, I'm going to show you how I factor. You don't have to use this method, but if you struggle to factor, I will highly encourage you to use this method. But if you can factor without doing this, it's okay. So I say, okay, I look at the 32. I know that I've got to have a 4 and I've got to have an 8 because those two multiply to give me 32. Now all I do is I multiply it out. So I take x times x and I just write it over to the side here. That's x squared. And I would have 8x. Then 4x. Then 32. I don't put in any plus or minus. Now I figure out what the plus or minus have to be. So I've got to have a negative here. This is negative, which means I must have negative positive. Questions to that point? Cool. Now I just need to make sure that this is the same as this right here. So negative 8x means I must have a negative there. Positive 4x, I gotta have a plus there. Now I'm done. So the next line, sorry for hurrying, the bell's coming. Limit as x approaches -4. These are factors, so I can rearrange them. I would end up with x plus 4 divided by x plus 4. If x is equal to -4, that's going to be undefined. But I'm finding a limit, so I don't care. I don't want x to equal -4. I just want it to be close. So that means this will equal 1. And I'm left with x minus 8 over x minus 4. The bell's going to ring. I'm going to keep talking. If you need to pack up and go, keep going. I just want to finish the video so I have a record of it. So now I just have to think. When x is close to -4, this is going to be really close to -12. Doesn't matter if it's a little more than -4 or a little less. I do have to think of both. The bottom, this is going to be close to -8. So now I know the limit is simply 3 over 2. That's the y coordinate when the x coordinate is a little more or a little less than 4. Question? Please.
Where do we get -12, -8? Just subtracting -4 from -1?
We basically said, okay, again, if you need to go, go ahead. I'll just keep talking. You can watch the rest of it on the video. I have my formula, right? This is how I calculate my y coordinate. But through factoring, I was able to rewrite the formula in a more easily understood way. Are you good there?
Yeah.
Because now I know that if x is almost negative 4, this will equal exactly 1. Close to negative 4 plus negative 8 is close to negative 12. Close to negative 4 plus negative 4 is close to, did I answer your question? Okay, so that's where that came from. I still have to do the horizontal asymptote stuff. Well, I don't want to use the beginning to do the horizontal asymptote. Let's do something easier. This formula is exactly the same as this formula. And if x doesn't equal negative 4, this very simple formula is the same. So I'm just going to do the limit as x approaches infinity of x minus 8 over x minus 4. Now I just compare again. The only thing that's going to matter is the x. So really, I can put equal limit as x approaches infinity of just x over x, because I compared the terms that add again. Now I know if x gets really, really positive or really, really negative, either way it's going to equal 1. So the conclusion would be as x approaches infinity, y is going to approach 1. As x approaches negative infinity, y is also going to approach 1. We have a horizontal asymptote at 1. Sorry for the hurry. The fire drill made things a little bit hard. Good job, you guys. Question? No, for power functions, I don't think I've ever seen a case where it isn't the same. When we have exponentials, it can be different. The reason is this. So here's the key things to understand, Paige. We started with a formula.
This might take
Right? Good job, you guys. Once factored, we got an easier to understand formula. But the two orange boxes are exactly the same thing. Now I know that if x is approaching infinity, this is just going to be 1. If x is approaching negative infinity, that's going to be 1.
It's the same thing.
It's the same thing. This orange box is actually always 1, except if x equals negative 4. If x is negative 4, you'll have 0 divided by 0, which is undefined. So unless you're answering a question about x being negative 4, that thing's 1. So that gets me all the way to this nice, easy formula now that I can work with. So right here, when I'm finding the horizontal asymptote, I'm just doing a limit problem again. I'm going right back to here. I'm comparing terms that add. But it doesn't matter if x is really positive or x is really negative. Like, think about it. 1 trillion plus negative 8. Pretty close to 1 trillion. A negative trillion plus negative 8. Still really close to 1 trillion. So it didn't matter whether it was positive infinity or negative. In some future cases, we'll say, oh, wait a minute, it does matter. Because everything doesn't behave the same way as this. But anyway.
Okay.
Good work, you guys.
So we use power functions when we're looking for difference.
No,
Approach.
we're just using what they gave us. Yeah, they simply asked us to find the limit, and that limit involved just power functions. It did make things a bit easier. The next packet involves exponentials, which is not really harder. You just have to be a little more on guard. So, good job, you guys.
How did you
Thank
get
you so much.
negative 12 over negative 8?
Come up here, Sabrina. So where did this come from?
From this.
Gotcha. So are you okay that this is exactly the same thing as this?
Yeah.
Awesome.
Oh, wait. Well, I
Go
know
ahead.
it's the same thing as that.
This one here? Okay, so you're good that these two are the same. Awesome. All I did from here to here is I said, because this is just two factors, meaning they're just two things multiplying, I can multiply them in any order I want.
Oh.
So I just separate them, and I did the same on the bottom. So I just rearranged the order, because if you multiply them back together, this,
So don't
go
these
ahead.
not cancel out, but just get rid of them, turn into one?
That's where you have to be a little bit careful, but close. So you're talking about the x plus 4 over x plus 4, correct?
Yeah, wouldn't you just have this now?
We're close. There's only one exception. If x equals negative 4, this will become 0 over 0, which is undefined. So as long as we're not going to let that happen, we're okay to call this 1.
Okay.
If that makes
So
sense.
then we have 1, and then how do we go to 3?
Gotcha. So because x is not going to equal -4, it's only going to be close to -4, we're fine to call this 1. So now we think, okay, x is close to -4. So what's -4, not, well, close to -4, plus -8?
About
About -12. So we're getting really close to -12.
-4, not +4.
Because they're asking us to find out what happens when the x coordinate is almost -4.
Okay.
Did that make sense?
Yeah.
So whenever you get to that point in a problem, you would just do that. You just put in whatever it's going towards.
Well, it depends on the question, but in this case, that's what limit means.
Okay.
Limit is asking you to, it's always just x's and y's. It's saying, okay, you got x's and y's here. And we're interested in what's happening, not at -4, that's not the one we're trying to think about. We're thinking about a little bit less, and then a little bit more.
Awesome.
What does that limit do for you? If 3
Good job,
over 2.
Serena. Say again.
What does the limit do for you? Like, what can you do with 3 over 2 now that you?
For our class, the way this connects to what we did in the first packet, which I didn't, it's always a balance. Like, I don't want to ask you to spend too much time.
Right.
I'm asking like a whole bunch of things, but there's a direct connection. Because think about it. Think about what we did last night. Let's stop the video here.